Hello, my dear class 8 students. Today, our topic of discussion is turning effect of force, which is known as torque. Forces can make objects turn if there is a hinge. You must have noticed how a door turns to open when you push it. The hinge is also considered to be a fulcrum or pivot. Here, as you can see, this is the hinge of a door about which the door opens and closes. The turning effect of force is called the moment of force or torque or simply moment. Torque is the tendency of force to produce rotation. It is the rotational equivalent of force. A torque applied to an object will cause it to rotate around a pivot point or an axis of rotation. Torque is a force exerted at a distance from an object's axis of rotation. So, torque is nothing but the tendency of force to produce a rotation. The formula of torque is given by the product of the force, that is capital F. As you can see, the purple sign is the capital F here, and the shortest distance from the pivot to the point of application of the force. That means where I am putting the force, see the black knob, circular knob that is rotating, and from the pivot means the fixed point around which the force, the object is rotating. So it is given by that brown arrow, that is small r. You can take it as d also, small d, that is perpendicular to the force applied. When the force is being applied in anti-clockwise direction, then it is shown by this green arrow. And see the nature of this r and force applied. R is the shortest distance and the force applied, the angle between them, between r and f, is 90°. Here, as you can see, this angle is 90°. The angle between the force applied and the distance from the point of application of the force to the pivot. This distance is termed as small d or r, and F is the force applied. So torque is coming in this direction, that is the product of F and D. The symbol for torque is tau. The unit of torque is Newton meter. This is the same as the unit for work and energy, but there Newton meter was written as joule, but here torque is not energy, and hence its unit is just Newton meter, not joule. Remember this very nicely. The unit of torque is Newton meter, not joule. The factors which are affecting moment of force or torque is the strength of the force applied, that is the how much force I am applying on the body. More the force applied, greater will be the torque of the body. And second is the perpendicular distance from the axis of rotation or pivoted point. The larger is the distance from the pivoted point, greater is the turning effect of the body. So more the force applied, more is the torque, and more is the perpendicular distance, then also the torque is more. Consider an example by opening a door by pushing it. It is easier to open a door by pushing at a point away from the hinge than at the point close to the hinge. The hinge is the pivot. Now, when I am pushing a door with the same force, it is easier to push it away from the hinge, because then in that case the distance between the hinge and the point where the force is being applied is more. So the torque or the rotating force will be more. So easily with the same amount of force I can open the door compared to the force when applied to a point nearer to the hinge. Then the R, or the distance between the hinge and the point of application of the force, will be less. So the torque will be less, therefore it will be difficult to open the door. Children, see in this window pane, this is the hinge of this window pane. Alright. Now it is easier to apply the force like this. Here when I am applying this force, the distance between my point of application of the force and the pivot is this one. The distance is bigger, alright, compared to this distance. This distance is smaller, this much. That is the point of application of force. If I push it from here, then from this point to this point, the hinge, this will be my small letter D. That is the distance between the point of application of the force and the hinge. Alright. This distance is smaller compared to this distance. Now when I am pushing it from here, easily I can push this window pane. Compared to when I am pushing it from here, then with that same amount of force, it is being difficult for me to push this window pane. Why? Because in this case the torque is less. In this case the torque is more. Alright. You can try this as your homework at home. So my dear class 8 students, today your chapter 3's explanation ends over here. Hope all of you have understood the meaning of torque and its effects. Please remember the symbols and also the formulas. We will continue with the common examples and the remaining rest part of the chapter in our following video classes. Till then, take care, stay safe at home. Thank you, class.